Hello, in this video I'm going to give you a demonstration of how to work with properties in C#. Properties are analogous to the getters and setters that you normally use in C++ and Java. They are a public interface to private data. They help control how external objects can manipulate another object's state. So what I'm going to do is just make a class called circle, and when I change the radius of the circle, the area and diameter will change too. So there'll be three properties and they'll all be connected. So how would I make a new class? Well, I can, in the Solution Explorer, I can right click on my project, and then I can add add a new class down here. I can just go to the bottom and say I want a new class, and that'll create a whole new file. Or I can just add the class directly to my existing program here, which is just a console app. And I realize now that I want a class called Circle, but I'm in a namespace called Circle. This may cause a problem. Let's see. So to make a new class, if I just type the word class and hit tab twice, Visual Studio will stub out a class for me. I highly recommend that you let Visual Studio write as much of your code for you as possible, because that way your curly braces are much more likely to line up. One of the problems I see all the time is people not matching up curly braces. That happens when you don't let the environment, the development tools, write the code for you. If you let the Visual Studio stub out your code for you, the curly braces will almost always line up. So let's make a class here called Circle. And let's see, what does our class need? Well, it needs a constructor. That's the special function that initializes or sets all the data in the class to its initial values. And to have Visual Studio make you a constructor, you just type CTOR, it's kind of short for constructor, and it will insert the snippet for a constructor. So if I hit tab twice, there we go. Now I have a public constructor for my circle. And what will my circle, let's see here. Let's give, now let's go add our properties to our circle. Let's add a public property for the radius, the area, and the diameter. So to add properties for, well, for anything, if you just type PROP, prop, and hit tab twice, you'll get the snippet for a property. So this is an auto-implemented property that has a kind of a default getter and a default setter. So what this has done for us is it made a property called myProperty in caps, and it is allowing access to a private variable whose name we don't know and who we don't even see. So this is a wrapper around a variable that is kind of totally hidden from us. Let's make the radius of our circle a property. Radius, okay. And then let's also add properties for area and diameter. So I'll just copy that. And area. Okay, now this is where it gets kind of neat. Well, we know the basic formula for the diameter of a circle. Like the diameter is twice the radius, and the area is going to be pi times the radius squared. So they're not going to be able to set the area directly. They're going to be able to get the area, but not set the area. So we don't have to have both the get and the set. We can just have one. So let's remove the set property here, or the set accessor. So they're not, whoever's using this circle class is not allowed to set the area. They are allowed to get the area, but they're not allowed to set it. Now, when somebody tries to get the area for the circle, what should happen? Well, I should return them 2 times the radius squared. So how do I represent that? Well, I'm going to kind of just give myself some more space here. So the get accessor for the area property will return, let's see, math.pi times the radius times the radius. And why is it not have? Oh, probably because math.pi is a double. Okay, so so a double is a 64 digit or 64 bit floating point number, and I specified floats. Those are 32-bit numbers. So I could have just changed everything to be doubles. Here I'm just kind of typecasting down to a float. I'm just truncating down to from 64 bits down to 32 bits. But anyway, that's what that's doing, right? So just anytime somebody tries to get the area, then that will come into the getter here, and then we will do our little calculation and return it. So anytime you ask the circle for the area, it will do this calculation and return the value. All right, so what else? The diameter. Let's say, is somebody allowed to set the diameter? No, let's just say that that's the same thing. That's a get only property. So let's just remove the set, and then we'll put in the code for the get. If you are confused on like the syntax for a property, I remember it as it looks exactly like a function call, but without the parentheses. There's no parameter list on a property because, well, it's just you can kind of you can imply it, or you can infer it from the property itself. You just don't need to have an argument list. So what does it mean to get the diameter? Well, we just return 2 times the radius. There we go. So anytime we try to access the diameter, we will return 2 times the radius. And let's see here. Okay, and this is pretty good. Let's say we wanted the default radius of the circle to be 1. How would we do that? Well, on the end of your property, you can just say equals 1, and then this becomes the default value for that property. So now we have a property called radius that we can get and set, and we have diameter and area. Those are get only properties, right? And when we try to retrieve those values, their values will be computed. Now, another way we could have done this is when in the setter for the radius, we could do these calculations in the setter for the radius, and then just have these be auto-implemented properties. So when somebody changes the radius, at that point we change the diameter and the area, which actually might be a little bit more efficient, which might be faster. Depending on what are you doing more. Are you getting the area more, or are you changing the radius more? If you just sort of set the radius once and forget about it, then it makes sense to do the calculations there. If you're getting the area a lot, you're asking the circle, hey, what's your area? Then it's going to do that calculation a lot, and that's a little less efficient. Okay, and then finally, let's go work on our constructor here. So if right now we have the default parameterless constructor. Let's add another one here, CTOR, and let's say that this constructor takes a parameter called radius, and we'll set the internal radius property, or radius property, to whatever was passed in. So now we have 2 constructors. We have a parameterless constructor and one that takes a parameter. It is totally fine to have 2 constructors. Most of the time you do. If you don't add any constructors, you get one by default. The compiler will sneak one in there for you, and the purpose of that is if you don't have any constructor at all, then there would be no way to create the object. So the compiler will say, okay, look, I'm going to at least give you a default no parameter constructor that calls your base class's no default parameterless constructor, and that way you can instantiate the object, and it does the entire. And if that object is part of a hierarchy, it will be built from the bottom up. So let me put that back in there. Control Z. There we go. Okay, so now let me write a little test program here. Circle equals new circle 5. So I'll make a circle with a radius of 5, and let's see, console.writeLine. The diameter is, I'll do it the kind of official way, the less lazy way. So the curly braces 0 means that's the placeholder for the first thing I supply here. So C's diameter. Let me copy that, and then I'll just print out C's area. And then let me hold the window open with console.readKey. And let's run it and see if it works. I'm going to put a breakpoint. I'm going to hit F9 on the first line of my function, and let's run it and step through it and see what it does. Oh, and of course, as I always do, I forget to set the startup project to the one that I'm working in. So all I did there was I just went to the solution I want to run, and I said select, or set as startup project. And now I'll start that. Okay, so now I'm going to hit F. I've stopped on the line where you can see the yellow arrow. Now I'm going to hit F11 to step into that function call, and you can see that radius is being set to its default value. And now I'm in the constructor, and radius is now being set to whatever radius was passed in. And I'll hit F10 to just keep walking. So now I have a circle. And if I hover over this circle, we can expand it and look into it. You can see its area is 78, its diameter is 10, and radius is 5. So that all looks good. So that's interesting because the debugger, in order to display those properties, had to call the getter. That's actually pretty cool, and I didn't really think about that. But now let me step into this property here with the F11 key. But you can see this looks like a variable. I'm using this property like it's a variable, but it's actually a function call, right? When I call when I get the area property of that object, I basically step into that property and I execute that code and return a value back. This is really, c.area is really a function call, but I get to use it, but I use it as though it were a variable. And that's one way of thinking about properties. They're getters and setters that we interact with as though they were variables, or using the same syntax that we would use to interact with a variable. So I'll just, I guess I'd already executed that, but there you go. So there's an example of properties, right? So properties, let's go back to our circle. Properties are C#'s replacement for the traditional getters and setters in Java. And we've seen here that they can be get, they can be set, they can be one or the other. We can provide them default values, and we can use them to compute values as soon as they're accessed, or we can kind of connect them together. So we had talked about how, well, all right, maybe when we set the radius, that propagates to setting the diameter and the area, right? So imagine you had a clock. If you set the minutes or the number of seconds on the clock to 61, then the clock could say, hey, you know what? 61 is not a valid number of seconds. That's actually that's 1 minute and 1 second, right? It can kind of adjust its other variables as it needs to. So that's another advantage of properties over just having a public, making your variables public. You can perform validation on your properties in these setters and getters as well. Well, mostly in the setters. So there you go. Hopefully that's somewhat useful as an example of how to use C# properties.